So this doesn't seem to have much of a real-world application. So I'm going to talk to you about what engineers do a little bit with this thing. This is the last problem on the quiz, and this is where, you know, the real world meets things. Now, you can graph the flight of a ball, which we're going to do on Monday. You can graph the size of a box or the size of a board. You can graph a lot of different things using a parabola. All right, and here's how. We've done one of these in class, but I want to do this for you anyway, so that we can really kind of cement this relationship between graphs and the physical world around us. A store has a rectangular signboard. I stop right there and I say, "Oh, Mr. Rob, can I use scratch paper?" Mr. Rob says, "Yep, you can use scratch paper." So I go grab a piece of scratch paper and I draw a rectangular signboard. There's a rectangular signboard. All right. Now, don't worry about whether the width is correct or the height is correct. All you need to do is draw the rectangle. Well, I don't know what the measurements are, so I don't know which one will be right. Well, it doesn't matter a lot. It says it's a rectangular signboard with dimensions 7 minus x meters by 3 plus x meters. So I'm just going to write down 7 minus x on one side and 3 plus x on the other. I don't know which one of these is longer, but it doesn't really matter. It says the area of the signboard is a meters squared. So that's my picture. Now typically when we find area, what do? Well, area is length times width, isn't it? It's still length times width, even though we're using variables and garbage now. The area of any rectangle is still length times width. It's just that the length is funny and the width is funny. But we still use this understanding and this idea. Cool? Now, it says express A in terms of x. So it wants me to express area in terms of x. Well, I'm just going to simply write what I know. Area has to be 3 plus x multiplied by 7 minus x, because that's the length and that's the width, and that's what the formula for area is. So the answer to letter A here on number 4 is area equals 3 plus x times 7 minus x. Now, could you write 7 minus x times 3 plus x? Of course, absolutely you can. Yeah, cool. Now, if you notice, we have this little double bubble situation, and in my mind, I'm thinking, oh, let's just multiply that out. Let's distribute and get this into a quadratic form. So, what's 7 times 3? 21. What's 7 times x? Negative x times 3. And negative x times x. Okay. And now I've got this set up, but I notice I can combine like terms. So that's the same thing as 21 plus 4x minus x squared. And then I realize it's not in the order that we usually deal with parabolas, so I'm just going to switch the order around and write negative x squared plus 4x plus 21. And this is kind of what I'm going to use as I graph this equation. So it says express A in terms of x. This is acceptable, absolutely. This is also acceptable. Cool? All right, so now it says draw the graph of A against x for x between 0 and 7. Oh, well, once again, I'm going to use a t-chart. There's x, and there's the area. All right, so when x, I don't want to do all 7 of them. I'll just do 0, 2, 4, 6, and maybe 7. Cool? It's an odd number, so I'll throw that one in there. So when x is 0, What's A? What's the area? Oh, I don't know. Let's check it out. Area is equal to negative 0 squared plus 4 times 0 plus 21. So the area is 21 when x is 0. Notice I've given you the correct scale here. It goes up to 25. We might start to worry about it later. I don't know, but we'll see. Now, once again, we're dealing with area. I'm sitting here worried about whether I have enough room on my paper, but we're dealing with area. So this stuff right down here, I'm never going to use this part of the graph, am I? So I'm going to start writing my formulas in here if I need to. Well, let's put 2 in. A equals negative 2 squared plus 4 times 2 plus 21. Now here's where a lot of you are making a mistake, okay? This is not negative 2 squared, okay? It isn't. It's not negative 2 squared. You don't square the negative. You square the 2 and leave the negative where it is. Okay, so this is equal to a negative 4 plus 4 times 2, which is 8, plus 21. 21 plus 8 is 29. 29 minus 4 is 25. So when x is 2, a is 25. Okay? All right. Well, let's plug in 4. Sorry, I keep scooting that a little bit off the thing. If I plug in 4, I get a equals negative 4 squared plus 4 times 4 plus 21. 4 squared is 16, so that's a negative 16 plus 16 plus 21. Well, that makes things easy. Area is 21. So when x is 4, the area is also 21. And now I don't have much fear of just plotting that, 4 comma 21, because I realize I'm working with parabolas, so that's what's going to happen. And I think I may have found my line of symmetry. Okay. Can you recognize that, how that's symmetrical right there? Well, let's keep going. A equals 6 gives me negative 6 squared plus 4 times 6 plus 21. 6 squared is 36, so that's negative 36. 4 times 6 is 24 plus 21. Negative 36 plus 24 is a negative 12 plus 21, which equals, what's 21 minus 12? How about 9? So going to 6 brought me down to way down here to 9. Okay. Let's put one more in. Let's put 7 in. A equals negative 7 squared plus 4 times 7 plus 21. And what you'll notice is this number gets bigger really fast. I guess you could say smaller really fast because it's being squared. And so it goes faster than this middle term. So this is negative 49 plus 7 times 4 is 28. See, we're still in the 20s at 24, 28, while this one went from 36 to 49. Squaring something makes it move up faster than just multiplying it by a number. So negative 49 plus 28 plus 21. Well, let's see. 49 minus 28 is a negative 21 plus 21. Oh, that gives me 0. So when x is 7, the area is 0. What that means is I've kind of graphed all the possibilities once I draw this line. I've kind of graphed all the possibilities of how big this box can be. And if you think about it, if this right here is one side of the box, if x is 7, 7 minus 7 is 0, that would mean the size of one side is 0, and you can't have a side be 0. And I could go x is negative 3 if I want. So I could go all the way to negative 3 for x. All right. And still have that side be greater than 0. Once I'm at negative 3, the side is 0, so the area of the box is 0. So that's kind of what my parabola set is. And I didn't ask you to graph this part. I just graphed it to kind of show you the symmetry. Cool? So we've expressed a in terms of x, and it says draw the graph. Well, that's right there. All right. And then it says find the value of x that gives the greatest area of the signboard. Well, this is where the math meets the physics. See, if I have a rectangle, and one side is x minus 7 and one is x plus 3, if x is 7, 7 minus 7 equals 0, this side would be 0 units long, and that can't happen, can it? If x is negative 3 and I have it adding 3 to it, this side would be 0 units long, wouldn't it? So x has to be between negative 3 and 3. And as this one gets smaller and this one gets bigger and things like that, stuff happens to this rectangle and it gets long and skinny. So like when x is maybe, oops, it's 7 minus x. I'm making another mistake. Like when x is maybe 6, that means this is only a 1 and this is a 9, right? But what if x is 1? When x is 1, that would mean this is a 6 and this is a 4. Can you see why I told you it doesn't matter what size rectangle you draw because it's going to fluctuate? Well, 6 times 4 is 24 and 1 times 9 is 9. So even though I might have x, so there are times when the rectangle will be much smaller than other times. And that's when we're down here on the graph. When x is 6, the area is only 9. When x is 6, the area is only 9. When x is 4, the area is 21. When x is 4, I have 7 here and 3 here. 7 times 3 is 21. All right? So this graph is a real representation of the size of the sides compared to the area of the rectangle. And the largest possible area, since this right here, since this axis is the area and this axis is x, the largest possible area this signboard can get is 25. Okay, but it says what is the value of x that gives the greatest area? Oh, well, when x equals 2, the area equals 25. So the greatest value of x that gives that area is 2, or the value of x that gives the greatest area is 2, and that area is 25. 2, 25. I hope that helped you understand the quiz. If you didn't quite get this, watch it again and again and again. Remember, just like in language arts, when you're drafting in mathematics, understanding comes through multiple drafts of listening and watching and trying things, okay? So if you need to, print off a copy of this quiz and do it again. Do it over and over while I do it online, okay? Until you get it. All right? See you later.